taken from Chapter 7.3, Hypothesis Testing for the Mean in Small Samples. And there's an example under Tools for Success that is almost identical to this example. So we're going to take a look at that in just a few minutes, showing you how to use the calculator. You receive a brochure from a large university. The brochure indicates that the mean class size for a full-time faculty is fewer than 32 students. You want to test this claim. You randomly select 18 classes taught by full-time faculty and determine the class size of each. The results are listed below. At alpha equal to 0.01, can you support the university's claim? And these are the classes that are listed. That's the 18 classes that are listed. Here's your claim, because it says here fewer than 32 students. So remember, the null hypothesis always has equal, so this has got to be the alternative hypothesis, and that's going to be your claim. H of A is less than 32. And I want you to use technology to find the p-value, because that's so much easier. And this comes from exercise 29, page 396, and it's almost the same question. The one I'm doing came from an older version of the book, and it's at the 0.01 level, and alpha is 0.05 in this example that's in the book. So we're going to take a look at that in just a few minutes. But anyway, the first thing you want to get is t, and we know that this is x bar here, and that's not just x, that's x bar is equal to 30.167, and you're going to subtract 32 from it because 32 was our claim, and this is the standard deviation, and this is your sample size, which is 18. And so if you work that out, you're going to get negative 1.942. Now if you had done this on the calculator, you would automatically get this answer. So I'm going to flip to the calculator real quick and let you take a look at that. So what you do is you go and you put your data in L1. So you would list all of your numbers in L1, and remember, you only do this when your sample is less than 30, and our sample was 18. You're going to go to Stat, over to Test, and you're going to take the second choice, which is T-Test. If you're using an 83, it might not be the second choice, but find T-Test. Select the data for input. So here where it says input, you're going to put data. You're going to put 32 for your sample or your claim. You're going to put that your stuff is in your L1 list. Your frequency is 1, and because the claim is less than, we're going to use this less than symbol. Then it tells you to go to calculate. Go to calculate and press calculate. So you'll move down to calculate, and you'll hit enter after you do that, and then that's going to give you your t-test. That's what we just found with that formula. So you can avoid using that formula if you use the calculator, and it automatically gives you your p-value also, and it automatically gives you your mean and your standard deviation and tells how many entries you have. But our p-test would be 0.033 4 if you're going to round it off, and so you'll see that's what I had on that problem. So then you can choose draw and press enter, and it drew it where the where t is, and so t is negative 1.9, which is almost negative 2, and the p-value is 0.0344. Now this one says that you're going to reject the null hypothesis because it's a level 5%, but remember, that's not exactly the problem we were doing. So we're going to run back here before I run out of time, and there's your p-value, and we found it on the calculator. But in my problem, the one that I did, alpha was 0.01, so when p is greater than alpha, you fail to reject the null hypothesis, and then there's the claim to interpret it, because you want to interpret the decision. There is insufficient evidence at the 1% significance level to support the claim that the mean class size for full-time faculty is fewer than 32.